Hello everyone, welcome back to the Hack the Gap Learn the Skills series. In this episode, we are exploring the injection category of CTFs present in the CyberGym. First, we'll start with NoSQL injection specifically, the NoSQL manipulation challenge present in CyberGym. Our objective is straightforward. We'll see how a single crafted request can update product reviews in the database. More importantly, we'll understand why this vulnerability exists and how attackers can abuse MongoDB query operators when applications don't properly validate user input. So let me just run down the concept with you as to what NoSQL injection is before we jump into the demo. So unlike traditional SQL databases, MongoDB stores information as JSON objects. Many applications take the JSON sent by users and use it directly to build database queries. If the application expects a simple value because of MongoDB implementation, it could end up accepting a JSON object which might contain malicious database operator. So this meaning itself, the meaning of the query itself changes completely because of malicious database operators, and that's where the NoSQL injection generally happens. Instead of manipulating SQL syntax, we are manipulating database operators to change how MongoDB searches documents. So on today's challenge, we'll figure out how NoSQL manipulation exists, why it exists, and how to solve this particular CTF. As the CTF is shown, it's in the difficulty of 4 out of 5. Again, this rating could differ if you are new to cybersecurity, then it will be 4 out of 5. If not, it's a pretty straightforward challenge for you to solve. So as you see in CyberGym, there are various artifacts that are present which you can add it to your basket, and some of these artifacts has customer reviews. There's an option where customers can write their reviews. So our objective is to change all of those reviews. So normally the application should update only one single review when you end up typing in your review. But if the server blindly trusts whatever JSON we send, then we can end up manipulating the database query so it matches every review which is already present in the collection instead. So this is how NoSQL exfiltration happens. So let's dive into how to solve this using Burp Suite, and I'll give you a quick demo of what are the tools you would require and how you would get started with it. So now that we have an understanding of the concept, let's see how I would normally solve this challenge manually using Burp Suite. This is exactly how a penetration tester would usually do, which is analyze the application before thinking about payloads or automation. So step 1 would be understanding what the application actually is. So the first thing I would want to know is which API endpoint updates product reviews. So every action you perform in the web application generates an HTTP request. So I open Burp Suite, I turn off intercept mode initially, and then I open browser on Burp Suite. Then I type in cybergym.hackergpt.app. That's our test target. Let me go to the scoreboard immediately. Yes, there we go. Okay, I had logged in earlier. Let me just log out. Okay. Scoreboard, injection categories, and what we have to find. We have to solve NoSQL manipulation. That is to update every record which has reviews. So let me see hints. Okay. Now I guess I have a basic understanding of what the challenge actually is. So let me go back to Burp Suite. immediately. Before I go back to burp suit, I just want to show you. You can just Google MongoDB NoSQL Injection NE, and it explains as to what kind of injection attack you could be using. So as you can see, the general term for this attack on MongoDB is NoSQL injection, often specifically referred to as MongoDB operator injection. And how it works is an application checks credential using username and a password with both user inputs. And if a user injects NE with value of null as password, the query evaluates to username of admin and password of NE with the value of null, which basically means that it ends up returning the first matching document, and it successfully ends up bypassing authentication. So NE means not equal, so hence it gets the name of MongoDB operator injection as well. So now you know bit regarding what operator you would end up using for this particular injection. Okay, great. NoSQL. Okay, we have to end up updating product reviews. So here's a product, best CyberGym salesman artwork, and as you can see, there are multiple reviews that has already been written. And initially there have been few people who did solve this CTF, and they have written and someone has updated the reviews to NoSQL being pawned. Alright, so our objective is to update all of these reviews that were already written into a new review. Okay, let me just first log in with a new account. Test at hackerGPT.com I had initially created. Let me log back in. It's a very secure password. Okay, so let's go to the categories and let me just write a review. I am writing a new review for testing and submit. Okay, as you can see, my new review has been updated with the username of test@hackerGPT.com. And when I come back to burp suit in the HTTP history in proxy, let me filter it to review so that I get only responses from of review. Okay, I see a GET request. Okay, yeah, this is interesting. As you can see that there's a message which says NoSQL pawned and author of Stan Juice shop, something like that, right? Okay, cool. So now we know what are all the key value pairs that are there in the JSON in the request part. Okay, there's ID also. This is important for us to know, and this product number as well, that's also important for us. Okay, so let me see. Okay, this is interesting. You see there's a put request. Let me send Scroll, let me find it. There you go. This is the put request. Let me send it to the repeater. Repeater of burp suite is very helpful because you can edit whatever request you want to send. You can even change the request type from a put to patch or post. Let me change the message now. Now I'm going to change the message to manual NoSQL pond, and yeah. Okay, we need ID, so I'm just going to grab the ID and I'm going to replace it with the author is, and yeah, I'll replace that with the ID that I had copied earlier. And I'm going to hit send. So yes, our payload has been successfully injected. Okay, let's review this. Let's check the new GET request. Yes, as you can see now, whatever I had initially written, it's gone. Okay, this is actually a new product, and yeah, it has now a manual NoSQL pond written. As you can see, I have not mentioned author in my payload, so hence there is no author present. So let me just copy that and let me update author. I'll add author as well now, which is test at HGPT. Let me copy author. Okay, test at hgpt.com. hgpt.com. Perfect. And let me update the message so that we know if okay. I forgot to add a comma right after author. Okay, let me resend it. Okay, our payload has been successfully injected, and yes, as you can see now, test at hgpt.com has manual SQL repond review written. Let us check the GET request and review it. Okay, yes, as you can see, whatever we had written has been updated. And let me go to the injection. Yes, as you can see, update multiple product reviews at the same time has now been completed. So before I get started on solving the NoSQL challenge on HackerGPT, I'll just give you a quick review of how I solved it manually. The first thing is, as you can see, I wanted to figure out all the API endpoints were, which updates the product reviews, and immediately I did find it. For example, I just logged in and I updated one of my own product reviews, and as soon as I submitted it, Burp captured the request before it reached the server, and this let me inspect everything the browser was sending. So as I saw that HTTP method, the request URL and the headers, authorization tokens, and all the JSON body was shown, and then I sent that to the repeater, and what I noticed was two important fields, which was first was the review ID, which basically tells the server which review should be updated, and the second is the message field. That's simply the new review text. The review message field, the review message is interesting from a security perspective, but the main important thing is the ID. So I went back to the get ID and I found the ID. That's how I solved the NoSQL thing. Now let me see how I am going to do it with HackerGPT. So scoreboard, I am going to, for the following target CyberGym solve this particular CTF, right? Okay, NoSQL Manipulation. Let me paste it. Let me click on CTF mode. So let's see how HackerGPT approaches this particular CTF challenge and whether it can identify the vulnerability and generate the exploit on its own. So as you can see, the browser navigation is navigating to CyberGym. Okay, there is a P missing. Let me check the input prompt I gave. Okay, that was my mistake. Let's see if HackerGPT can figure out on its own what the correct test target is. Yes, it did. Okay, great. Browser is navigating to CyberGym .hackergpt.app. And there you go. It did find out the test target. Let's check and validate. Yep, that is our test target. As you can see, HackerGPT as well has a very similar interface compared to Burp Suite's interface of HTTP history under the proxy table. Okay, so as you can see, HackerGPT has also mapped out various endpoints. You can even copy curl commands and paste it, which is very similar to send it to a repeater. Instead, you can just execute these curl commands from your own terminals. You can replay these payloads as well, and you can save these payloads. As you can see, very similarly, it has mapped out various endpoints. Let me open up Burp Suite so that I can give you a quick comparison with respect to how HackerGPT and Burp Suite are similar in terms of mapping out all the endpoints of the web application. I'm navigating to CyberGym, and in the proxy HTTP history, you can see various endpoints very similar. All the GET requests are here, GET, posts, requests, everything's here. Let's filter it to search, and all your search requests are here. You can send it to repeater. Very similarly, in HackerGPT, you can just copy the curl commands and you can test it out in your own terminal as well, right? Okay, let's see. Okay, reviews. Okay, you can replay. Let me just quickly save this payload. Review. Let's check it in Burp Suite. Are there any reviews? Okay, let me just check out the reviews. What are the reviews that are there? And there you go. Product 42 has a review, and I just sent it to Burp Suite. And yeah, I have played the payload. Very similarly, you see the whatever payload it has a response 200 success. Oh, you can see that NoSQL Manipulation injection has been completed. The patch request was successful and all the records has been updated. Multiple product reviews. What we had done was, when we were testing it out manually, we ended up updating just one product review for a specific author, whereas HackerGPT ended up updating it for multiple product review. HackerGPT found out the underlying services and versions as well, MongoDB, Nginx, and Express.js. It did find out credentials, tested Juice Shop. It found out the vulnerability, NoSQL injection in patch. That's a REST product reviews. It also performed the action as well. Let's check it out. Yes, as you can see, all the authors' reviews have been updated with the message HackerGPT had sent, which is NoSQL injection being successful. So first, what HackerGPT did was it did reconnaissance, it did the front-end analysis which was required, that was reviewing the patch endpoint and then coming up with the necessary step. It also did log into a test credential. It found out the JWT token. It found out a test account as well. Unlike what we did, we had created our own account and using that token we did update. Whereas HackerGPT found out the test account as well, and then it modified, and it modified for all the reviews of all the authors, unlike us. So let's check it out. Another product review. Yes, this one did not have any reviews to begin with, so it didn't change. NoSQL injection being successful. Yep, NoSQL injection being successful. Great. So let me quickly give you a brief idea regarding how HackerGPT ended up doing this. Like, as soon as I submitted the prompt to HackerGPT, it began the performing reconnaissance. It did identify the target, even though I gave a wrong test target web applications endpoint. It did find it out smartly. It also found out how the application was running. It was running on an Express.js backend with a MongoDB database. So this is already an important clue for HGPT because as we had established earlier, MongoDB application can sometimes be vulnerable to NoSQL injection if and only if user input is not properly validated. In this case, it was not validated, so HackerGPT ended up analyzing the front-end JavaScript bundle as well. And by inspecting the client-side code, it did discover the API endpoint, which was shown in the memory tab. It discovered it, which was responsible for updating the product review. The endpoint being patch/rest product reviews. It also found out test credential hidden inside the front-end JavaScript. So using the credentials, HackerGPT authenticated itself with the application and it did retrieve a valid JWT token. And this token was required because the review update endpoint is protected and only authenticated to users who can access it. Now, the interesting part was that instead of supplying a normal review ID, like how we did, HackerGPT noticed that the application may be directly passing user input into a MongoDB query. It generated the JSON payload a bit differently to our reasoning. The way it did was it changed the ID with the not equal operator with value being non-existent and message with NoSQL injection. So let's understand why this payload worked better. So normally the server expects the ID field to contain the identifier of a single review, as I had mentioned earlier. Instead, the payload HGPT provided was a MongoDB query operator of not equal. So the condition over here, what it did state was like, find every review whose ID is not equal to the non-existent value. So since no review has that specific ID, every review satisfies that condition, right? So instead of matching just one review, the database ended up matching all of them. So when the patch request was sent to the backend, every matching document was updated. And also mention that in the endpoint, I did mention a specific product that was /24 or 42, I do not remember. Whereas here, HGPT, when it was sending the payload, it did not mention any specific product. Hence, all the products and all the reviews were changed. As a result, not just one was modified, everything was modified. So the server also responded back the result JSON. You can just look into that with the response of modified with value 33, meaning that 33 products reviews were updated simultaneously. So basically this successfully completes the challenge. This is a classic example of NoSQL injection vulnerability caused by trusting user-controlled input inside a DB query, specifically MongoDB query. If the application had validated the input type, and if it did had enforced strict schemas or prevented MongoDB operators from being interrupted as query objects, if it did had done all of that, then this entire attack would not have been possible. So one thing I really like about HackerGPT is that it just doesn't simply provide the final payload, it performs a reconnaissance. It did identify the underlying tech stack I had mentioned. It found out all the relevant API endpoints similar to burp suite. It did authenticate properly, and it also crafted the exploit based on the finding, unlike burp suite. So it did find out the issue, and it also found out the payload. So that makes the reasoning process much easier to understand and comparatively simply by just receiving a single exploit request. So remember that this demonstration is performed only inside intentionally vulnerable websites like CyberGym.HackerGPT, and it's strictly for educational and authorized testing only. So I would strongly advise you to never use these techniques against systems you strictly do not have permission, or if you don't have access to, all right, explicit access to. There you go, that's the patch request, and that is the updated JSON payload. The patch request does not have a specific product ID. And let's check out the response. Response has success, and you can see various authors and products have updated with NoSQL injection successful as their message. If you would like to see more HackerGPT walkthroughs covering CyberGym and other challenges, do not forget to like and subscribe for future tutorial. Thank you for watching, and I'll see you in the next one.